today's class. For today, we're going to continue our concept on integration. So we're going to solve this problem using the concept of integration. So how do you solve this? What's the first task here? So for this question, my task says to use what we call the substitution method to solve this one here. So for number one, let's start number one. Number one says the integral of exponential 5x, next up, cos into 3 exponential 5x plus 4, next up, dx. So how do you solve this? How do you approach this question? First task, call the term in brackets, call it u. So let u to be equal to 3 exponential 5x plus 4. Of course, if I differentiate u with respect to x, right, from here, I'm going to differentiate u with respect to x. So have the u over the x to be equal to, if I differentiate 3 exponential 5x from exponential shortcut, I'll have 15 exponential 5x. If I differentiate 4 is a constant, it's 0, it's off. So from here, I'll try to make the x substitute the formula. So the x is now equal to the u over 15 exponential 5x. At this point here, substituting, I'll have that the integral of exponential 5x, next up, cos, we said this one here is u, that becomes cos u, the x value now is what? The u over 15 exponential 5x. Of course, exponential 5x cancels out exponential 5x. So I'm left with the integral of cos u, next up, dot 1 over 15. Perhaps I'm having the u over 15. Shift out 15. I'll have 1 over 15. Next up, the u. So it simply means 1 times the u, I'll have the u over 15, which is this here. So at this point, I'll pick out the constant term outside the integral sign. So pick out the constant term, which is 1 over 5, 1 over 15 perhaps, outside the integral sign in this manner. Next up, cos u, the u. If I differentiate cos u, I'll have what then? Sin u. I'll have 15 into integrate cos u with respect to u. I'll have sin u. Next up, plus c. This we call this concept of integration. So, but u was what? We said u was what from the question? U was 3 exponential 5x. Next up, plus 4. So putting u here, I'll have 1 over 15. Next up, sin u was what? 3 exponential 5x plus 4. Next up, plus c. Let's have to solve this question here. So let's try to solve number 2 and let's see how it works. Alright, let's solve this problem here. I'm having the integral of sine to the power 7x plus x the x. So how do you solve this? Which field function will I call u? Should I call sine xu or perhaps cos xu? So the one in the highest part here is 7. So in other words, I'll try to take u to the sine because u has the highest part here. So let u from here, let it be equal to sine x. If I rotate u with respect to x, I'll have the u over the x is equal to cos x. If it is sin x, I'll have cos x. Make the x solve formula. I'll have that the x is equal to the u over cos x. So from here, substituting, I'll have that the integral of, we said sin x to be u, right? Sin I'll have u to the power 7. This 7. Next up, cos x. Next up, the x. Beside the x here is what? The u over cos x. So cos x comes out to cos x. I'm left with what? The integral of u to the power 7. Next up, the u. So from here, I'll apply our general method of integration. So my task says if I integrate u to the power 7, I'll have u to the power 7 plus 1 all over 7 plus 1. Next up, plus c. From here, I'll have u to the power 8 all over 8 plus c. But we said u was what? Sin x. So differentiating u with respect to x, sorry, we said u was sin x. So putting u here, I'll have sin x to the power 8 all over 8 plus c. This is correct. Or I can write this as saying sin a to the power x. Sin x to the power 8 means sin x in 8 places. Sin a to the power x means sin x in 8 places. Same thing. So all over 8 plus c. This is correct. So we have to solve question 2, right? So let's solve question 3 and let's look into another concept under integration. Alright, so let's solve this guy here. So how you solve this is my first start is to make sin x subject perhaps sin x be u. So I'll have that u is equal to sin x from here. So the u over the x, of course, I'll have cos x. Make the x, subject the formula, I'll have that the x is equal to the u over cos x. From this point here, by substituting my given question, I have the integral of sin x. We just set sin x to be u. I'll have u. Next up, cos x. Next up, the x. The x value was the u over cos x. I'll have the u over cos x. Of course, cos x comes out cos x. Left with the integral of u du. Perhaps u du. Alright, from here, I'll have the integral of u du. So if I integrate u du, I'll have u to the power 1 plus 1 all over 1 plus 1. Next up, plus c. My final answer becomes 2 to the power 2 all over 2 plus c. But we said u. What was u? U was sin x. So I have sin x. So if I put in sin x here, right, I'll have sin x to the power 2 all over 2 plus c. So this is how to solve question 3 with the concept of substitution under integration.